students, welcome back. Today we are going to learn a very important example based on similarity of matrices. We have given a matrix 3 by 3 matrix and it is asked show that this matrix is diagonalizable. We have studied the condition of diagonalizability. In short, if AM equal to GM for all lambdas, then we know that the matrix is diagonalizable. So first we will try to find AM. For AM we require eigenvalues. So let us start with the procedure of finding eigenvalues. So for that, as usual, we require trace here. Trace is sum of diagonal elements. So this is 18 here. SMD, you can calculate. We have done so many times calculation of SMD. M11 plus M22 plus M33, and this is equal to 45. And if you find the determinant of this matrix, this is 0. So we know that if determinant is equal to 0, then definitely we can say that one of the eigenvalue must be 0. So the characteristic equation is determinant A minus lambda equal to 0. This is the characteristic equation, and we know the shortcut method for writing the characteristic equation. Lambda cube minus trace into lambda square plus SMD 45 lambda minus determinant of A equal to 0. So if you enter this equation in the calc, we will get lambda equal to 0, 3 and 15. So 0, 3 and 15 are eigenvalues of A. So all of you note here AM, algebraic multiplicity of 0 is 1, which is not repeated. So algebraic multiplicity for lambda equal to 0 is 1. Algebraic multiplicity for lambda equal to 3 is also 1. Algebraic multiplicity for lambda equal to 15 is also 1. Number of times, this value has come, that is the algebraic multiplicity. Now, there is, we have discussed in previous videos also, if eigenvalue is non-repeated, then we know that there is definitely one eigenvector associated with each of the eigenvalue. So here I'm going to calculate for lambda equal to 0. So you can put this, substitute the value of lambda in the equation A minus lambda into x is equal to 0. So here if lambda is 0, so A minus 0 into x is equal to 0. So in short, Ax is equal to 0. So we have A, which is 8 minus 6, 2. Second row is minus 6, 7, minus 4, 2, minus 4 and 3 into x1, x2 and x3. This is equal to 0 matrix, 0 column matrix. Now, here we have to select any two equations and use Cramer's rule to get the eigenvector associated with this. So I'm going to write in the equation form 8x1 minus 6x2 plus twice x3 is equal to 0. Second equation minus 6x1 plus 7x2 minus 4x3 equal to 0. Use Cramer's rule. By using Cramer's rule, we can find x1 divided by x2 divided by and x3 divided by is equal to some proportionality constant k, x1 divided by coefficients of x2 and x3, which is minus 6, 2, 7, minus 4, x2 divided by coefficients of x1 and x3, and x3 divided by coefficients of x1 and x2. So if you simplify, this is x1 divided by 24 minus 14 minus x2 divided by minus 32 plus 12 and x3 divided by 56 minus 36 is equal to k. So that is x1 divided by 24 minus 14, which is 10, then negative x2 divided by negative 20 and x3 divided by again 20 is equal to k. So we can write here x1 is equal to 10k, x2 is equal to 20k, x3 is also 20k. If I take k as 1 by 20, your first eigenvector is 1, 2 and 2. So 1, 2, 2 is the eigenvector associated with lambda equal to 0. So GM now we can calculate here. GM for lambda equal to 0, only one linearly independent eigenvector associated for lambda equal to 0. So GM is 1. So here for lambda equal to 0, AM equal to GM. Similarly, if you find for lambda equal to 3 also, GM is 1, and for lambda equal to 15 also, GM is 1. So in short, we can say that lambda equal to 3, AM equal to GM, for lambda equal to 15, AM equal to GM. So AM equal to GM for all lambdas, right? For all eigenvalues. So definitely by the theorem, we can say that here AM equal to GM for all lambda and matrix A is diagonalizable. Therefore, we can say that A is diagonalizable. We know that if matrix is diagonalizable, we can find D and M. What is D? D is a diagonal matrix whose diagonal elements are eigenvalues of A. First eigenvalue is 0, 0, 0. Here, diagonal element. Second is 3 and third is 15 here. So diagonal elements are eigenvalues of A. This is the D. And M is a modal matrix or transforming matrix or diagonalizing matrix whose vectors, whose columns are eigenvectors of A. So we have seen for lambda equal to 0, eigenvector associated with this is 1, 2 and 2. And similarly, if you try for lambda equal to 3, eigenvector is 2, 1 and minus 2. And for lambda equal to 15, eigenvector is 2, minus 2 and 1. So in this way, we can calculate D, which is a diagonal matrix, and M is a modal matrix, and given matrix is diagonalizable. We have used here the concept AM and GM is equal for all lambdas. I hope this is clear. Okay. Let me, summarize here what we have done for this example.